going to be, I guess, really the first official recording of a lesson. I did a practice one with 11.3, but yeah, this is the first one I'm going to link and send. Welcome to my basement as you're being filmed on my iPhone and my tripod and the board system that Mr. Clark jerry-rigged for me over the weekend. You're also with my dog Maggie, who, and she'll let me pick her up all like, come here. Oh, come here. Sit. Ooh. Here. My dog Maggie, who Olivia has asked to meet 100 times over. But yeah, welcome to my basement. This is going to be our recorded lesson, and it's going to be awkward, and it's going to be done in one cut, and I'll probably make some mistakes, so have grace with me. I don't even have a podium. I just have a little table thing with my book on it. And my handy dandy page of notes. And you know what I always say? As we go through this lesson, if I have a whole page of notes, I expect you to have at least a page, or if not more, of notes so you can reference when it's your turn to do your work. So, we're on 11.5, the distance formula, page 611. What you will learn: to find the distance between 2 points on the coordinate plane, to find a point at a given distance from a second point of the plane. Oh, now I'm out of breath from picking up Maggie. Okay, how can the distance between 2 points be determined? Consider points A and B in the coordinate plane, and make sure you're looking at this picture as I read it. So consider the points A and B. Notice that a right triangle can be formed by drawing, and it's the dashed lines they're talking about, drawing the dashed lines parallel to the axes through points A and B. These lines intersect, forming C, a right angle. Now it should be flashing in your brain given yesterday's lesson on 11.4 about the Pythagorean theorem and right triangles. The hypotenuse of the triangle is the distance between A and B. So A and B is what you started with. You drew these two imaginary lines, you formed a right triangle, but now they're saying A and B is the hypotenuse of the right triangle you formed. You can determine the length of the legs of the triangle and use the Pythagorean theorem to find the distance between the 2 points. Notice that AC is the difference in the y coordinates and BC is the difference in the x coordinates. So, AB squared is equal to AC squared plus BC squared, or hypotenuse squared is equal to leg squared plus leg squared. And then AB is equal to the square root of the other two. So by putting it under the square root symbol, it's just saying in the original theorem, it had hypotenuse squared is equal to leg plus leg squared. So they're saying take the square root, and then we're just good to go from there. So I have written the distance formula here and here. This one's more my reference than your reference, but make sure as you copy it into your notes, put it in bold, star it, do whatever you need to do, because that is going to be our formula for today's lesson. So the distance formula. You can find the distance between any 2 points in a coordinate plane using a similar process. The result is called the distance formula. And just to walk through what the distance formula is, we're back to our old games of where is Mrs. Clark's marker, but at least my eraser's here. So, just to elaborate on what it is, the distance formula, where D represents distance, distance is equal to your change in x values, so x2 minus x1 squared. Because the difference in your x's represents your first leg, and you square your legs in the Pythagorean theorem. So leg squared plus leg squared. Well, what are our other values? y2 minus y1, all because we're talking about the distance between 2 points in a coordinate plane. 2 points mean we have two x and y values. x2, y2, y1, y2. Or x1, y1, x2, y2. And now we're going to take the whole square root of this whole thing. It would be the same as if we had d squared. We would ignore the square root sign, but we don't want d squared. So we're going to go ahead and basically take the square root of d, and then what you do to one side, you do to the other side. So in short, the distance formula is the square root of x2 minus x1 squared, this is important, plus y2 minus y1 squared. Do not forget that little squared. It'll change your answer drastically. All right, let's look at example 1. So example 1 wants us to use the distance formula to find the distance between 2 points. Example 1. And the 2 points they give us are 2, 3 and -4, 6. So these are just 2 points that exist in a graph, and we want to figure out what is the distance between the 2 of them. Well, since we have 2 sets of values, we need to label one as x1, y1, then the second one x2, y2. It doesn't matter which one you pick to be either of them. It's the same thing as the slope formula. It doesn't matter which one you pick to be group 1 or group 2, so long as you're consistent throughout your entire problem. So I'm going to make this group 2 to represent all of my y2 and x2 values. So group 2, and then this one's going to be group 1. And what that really means is this is going to be plugged in for x1, and this is going to be plugged in for y1. This x value is going to be plugged in for x2, and this value is going to be plugged in for y2. And now all I'm going to do is take my formula, copy and paste it down, and plug in my information. So distance is equal to x2 minus x1, x2 minus x1. So -4 minus 2. Now it's in parentheses squared, so put it inside of your parentheses. Square it. Plus y2 minus y1. y2 from group 2 is 6. Minus y1. y1 is 3. And again, put it inside of parentheses, square it. That's part of your formula. And then we take the square root of the entire thing. All right. -4 minus 2 is -6 squared. Order of operations, we're just doing the operations out of our parentheses right now. Plus 6 minus 3, which is just 3 squared. Remember, all of it's underneath the square root sign, and so you all still equal to d. 6 squared, or -6 squared, is positive 36. Plus 3 squared is 9. All still within our parentheses. 36 plus 9 is 45. So far we have d is equal to the square root of 45. But do we want to leave it as the square root of 45? No, because that can be simplified. So just rewriting it up here, we have d is equal to the square root of 45. Well, what's a perfect square that can come out of 45? 9 times 5 is equal to 45. The square root of 9 comes out as 3. So our distance is equal to 3 times the square root of 5. And again, 5 stays in your box because it is not a perfect square. And so the most simplified answer we can give for example 1 is d is equal to 3 times the square root of 5. Alright, and now we're going to switch into our second example. And give me a minute to erase the board. Since we're doing the distance formula, before I even read the problem, I know I'm going to have a group 1 and a group 2 set. So I'm just going to go ahead and write group 1 and fill it in. Group 2 and fill in my information as it comes. And now let's read the problem together. Example 2, using the distance formula. Golf. Tracy hits a golf ball that lands 20 feet short and 8 feet to the right of her cup. Alright, we have a little coordinate plane, but how would we make sense of that to know which value goes where? It's 20 feet short. I don't super know what that one means. 8 feet to the right. Well, okay, if it's 8 feet to the right of a given point, I know that's going to be my what? It's going to be my x value. So I have 8 feet to the right and short 20 feet. So I have the ordered pair 8, 20. So I'm going to go ahead and put that in. 8, 20. And that's just from reading my first sentence. On her first putt, the ball lands 2 feet to the left. 2 feet to the left means we're into my negatives. So 2 feet to the left. And 3 beyond the cup, so 3 past the cup. So if the cup is here, 3 past. So now I have the ordered pair, -2, 3. And I just kind of filled them in as I went. And so give me a second to double check to make sure we put it in the right group. So it's similar to yours, and we did, so we're good. Okay. Assuming the ball traveled in a straight line, how far did the ball travel on her first putt? So again, basically they're saying she had a goal. She wanted to get it in. It didn't happen. She has something like this, not the actual points. But now they want to say, what is the distance between her 2 putts? Well, we can use our distance formula. We've established this is group 1, so this is going to represent our x1, y1 values. These are going to represent x2, y2. And again, same thing with the slope formula. It doesn't matter. You could switch your 2 groups so long as you are consistent. The reason for it is you're squaring each answer. So if you swap them, you'll get the negative version of the answer, but when you square a negative, it comes out positive. So it'll be the same. But, all right, distance is equal to the square root of x2 minus x1, so -2 minus 8. -2 minus 8, put it in parentheses, and don't forget to square it, part of the formula, cannot forget it, plus y2 minus y1. y2 is 3 minus 20. 3 minus 20, put it in parentheses, square it. All right. Ooh, this 20 is supposed to be negative, I'm sorry. Let's see why that is. Because the original ball fell 20 feet short, sorry. That 20 needed to be negative. Like I said, it's being shot in one take, so bear with me. So y2 minus -20. That means we now have a double negative. Just be aware of it as we work through this. All of this is underneath our square root. -2 minus 8 is going to be -10 squared plus 3 minus a minus 20 becomes addition, double negative. And so we end up with 23 squared. All of this is still underneath our radical for distance. -10 squared is 100. Plus 23 squared is 529. That's equal to distance. Add the inside terms together. Distance is equal to 629, or the square root of it. And now this can't be simplified any further. And your textbook tells you what would happen if you keyed it into the calculator. You can choose to either leave it as this, or take it further by using a calculator to square it. But if you do decide to go further with a calculator, make sure you leave this as your answer too, because this is your answer. You can just use a calculator to get an approximation. All right, that was example 2. Now let's look at example 3, which is going to be the same thing, still using the distance formula. But what they're going to do with example 3 is they're going to have you solve for an unknown variable. What if they give you the distance, but they take away 1 out of your 4 coordinates? Can you use the distance formula, to be exact, to find a missing value? And the answer is going to be yes. Let me erase. And I might have to erase this one too. We'll see. It's kind of a longer problem, so we'll see. I'll try not to, but I also want to make sure I'm writing in a way that's legible for you as well. All right. Find coordinates. Suppose you know the coordinates of a point, one coordinate of another, and the distance between 2 points. So again, suppose you have a coordinate of one point, one coordinate of another. So you have a coordinate and then half of the other set, and the distance. you can use the distance formula to find a missing coordinate. So example 3 gives us 3 pieces of information. They tell us we have the coordinate 7, 5. So we're going to make this group 1. And then they tell us we have part of a second. We have a, so that's our unknown value that we're going to be solving for, and negative 3. We're going to make this group 2. And then they tell us our distance is actually equal to 10 units. And with all of this information, our goal is now to solve for A. So step 1, take all the information they give you and plug it into your formula. I know distance is equal to 10. X2, well, that's my unknown value, right? Because I said this is group 2, so this represents X2, Y2, X1, Y1. But that's okay, I'm going to plug it in anyways. A minus 7, which was my Y, or not my Y, my X1 value, put it in parentheses, square it, plus Y2, so negative 3, minus 5, squared, all underneath the square root symbol. So, continue to solve, 10 equals, there's really nothing I can do here. So, I'm going to leave it as A minus 7 squared plus negative 3 minus 5 is negative 8 squared. And that's my next line. But now is an important moment to pause and to evaluate the expression as is and see if anything stands out to you. There's something tricky inside of it. Right now, we have A minus 7 squared. Something should be flashing in your brain from chapter 9, factoring. We have the difference of a perfect square. A minus 7 squared is the same thing as A minus 7 times A minus 7. That means it can be factored. A minus 7 is in the same form as A minus B squared. And because we memorized it, we know that A minus B squared is equal to A squared plus, or sorry, in this case minus, because it's minus 2AB. Minus 2AB plus B squared. And so we need to pull it out. We need to expand it to see if we can go any further so that we can start to isolate A. So because it's in A minus 7 squared form, we're actually going to factor it as A squared minus 2AB, where A is literally A and B is 7. So negative 2 times A times 7 plus 7 squared, which is our B value. So take a minute, pause your screen if you need to, write this down because I'm about to erase it. And I'm going to factor A minus 7 squared into its perfect square trinomial. So after we factor it, we should end up with A squared minus 14A plus 49 plus 64, because negative 8 squared is a positive 64, all still underneath the square root, is equal to 10. Alright, my next goal is going to be to get my like terms together. I can combine 49 and 64. They're freestanding, they're constants, they can be brought together. Nothing else can be at this point. So now I have 10 is equal to A squared minus 14A plus 113, all underneath the square root. And now remember, my goal is to solve for A. Whenever I have something in terms of factoring, where I'm solving for A, I know that means I'm going to end up having to A factor it, and then B is set it equal to 0. But before I can do that, I have to get rid of this radical. Everything is trapped under the radical, because remember, a radical sign is a grouping symbol. So I can't deal with any of it until I've canceled out my radical. Well, how do I cancel out a radical? How do I cancel out a square root? I do it by taking the square of it. If I square a square root, it just cancels out. But what I do to one side, I have to do to the other. 10 squared is 100. And now because I've squared the square root, I'm just left with the terms on the inside. So A squared minus 14A plus 113. My goal is to have this set equal to 0 so that I can factor it and solve for my individual values. That means I'm going to have to bring 100 over. So subtract 100 to both sides so that this term is set equal to 0. And now I'm left with a squared minus 14a plus 13 is equal to 0. All right, I'm now going to bring my work over here so that we can see it a little more clearly. All right, we have, just rewriting, a squared minus 14a plus 13 is equal to 0. Well, now I have to factor this polynomial so that I can set each of my individual a's next to 0. All right, so I need to look for what are my products of 13 that sum to negative 14. Because my sum is negative but my product is positive, I know that it has to be two negative numbers, because two negative numbers multiply to a positive, but two negative numbers add to a negative. I'm going to try negative 1 and negative 13. Negative 1 plus negative 13 equals negative 14. So those are my two factors. So I have a minus 1, a minus 13 is equal to 0. Set each one individually. A minus 1 is equal to 0. And a minus 13 is equal to 0. A is either equal to 1 or a is equal to 13. So I didn't solve for an exact value for a, but I learned it's one of two numbers, and that's good enough. So with that, we have solved all of our examples, and now you may start your homework. Bye guys!